Okay, Bismillahirrahmanirrahim. Hi everybody, welcome to my asynchronous class for data communication. So today we will continue our discussion, another subtopic in chapter 3. So today we will discuss subtopic 3.2, data communication interface and networking. On the usability of OSI layered networking model, like with any tool in your toolbox, you can view the 7-layer OSI model in a number of ways. In the case of OSI model, it can be used one, as a framework describing what functionality needs to be present in an end-to-end networking solution. Okay. 2, as a recipe on how to build a networking stack. And 3rd, as a particular implementation of that recipe, including LLC on Ethernet, CLNP on network layer, TP4 on transport layer, and so on. Okay, so you still remember the 7-layer OSI model? Okay, so this 7-layer OSI model can be viewed as these three first as a framework, second is the as a recipe, and third is the implementation. Okay, so particular implementation, number 3, particular implementation of that recipe, including LLC. So what is LLC? LLC is a logical link control. Okay, logical link control protocol refer to IEEE 802 reference. Okay, CLNP on network layer. So what is CLNP? CLNP is connectionless mode network protocol. It is an OSI protocol deployment. CLNS is the service provided by the connectionless mode network protocol, CLNP, on the network layer. TP4 on transport layer. TP4 means transport protocol 4, TP4. It is a full connection oriented transport protocol, TP4. So what challenges do we have to solve? So there are many challenges to solve. Okay, so for the connection between A and B. Okay, so first, in terms of connectors and voltage, in terms of encoding of information, units, bytes or bits, in terms of message framing, error detection. So these are the challenges. Error correction and recovery, congestion management or flow control, reliable transport, node and session identifiers, and also finding a path across the network. So these are some of the challenges. Then we also face challenges in terms of multi-vendor interoperability, multiple transmission media. Okay, multiple transmission media means between A and B there might be different kind of transmission media, for example, copper wire, optical fiber, and also wireless. And lastly, an astonishingly multiple range of speeds, from as low as in kilobit per second to the fastest range of speed in terabit per second. So, and some more, this system must be very reliable, and most important, must be cost effective, aka must be cheap and affordable. So these are the challenges that we need to solve. Okay. Next is the data segmentation and assembly, data link layer. So this is the second layer of OSI model after the physical layer or hardware. Okay, data link layer. Okay, in data link layer, we will deal with data framing. The data link layer needs to pack bits into frames. Okay. Okay, so the data flow 01001 will be converted into data framing. Okay, so what is the meaning of data frame? Let me read. A data frame is a table or a two-dimensional array, a like structure in which each column contains values of one variable and each row contains one set of values from each column. Okay, so that is the meaning of data frame. The data link layer needs to pack bits into frames so that each frame is distinguishable, is different from another. Our postal system practices a type of framing, the simple act of inserting a letter into an envelope. Separate one piece of information from another. The envelope serves as a delimiter. So in data framing, we will deal with a delimiter. So what is that? Delimiter is something such as a mark or symbol used to show the beginning or the end of separate elements in a text or in a frame, in a computer program, or etc. This line of code use the comma as, normally if you do coding, you use a comma as a delimiter. A space is probably always considered a word delimiter. If macam kita, like we are writing sentences, space or period or titik, dot, can be considered as a delimiter. Okay, sometimes we use a semicolon as a delimiter. So macam-macam. Okay, so we will see in the next example more about delimiter. Framing. Data link layer is responsible for something called framing. Okay, so data link layer, layer nombor apa? Layer number 2, right? In this layer, there is something called framing, data framing, which is the division of stream of bits, the flow of data 101010, that is called stream of bits, from the network layer into manageable units called frames. each frame. So network layer ni layer nombor apa? Number 3, right? Into manageable units called frames. Each frame consists of sender's address and a destination address. So in the frame there is sender address and destination address. So this is something mentioned just now about framing. Yeah? So back to the definition of data frame. So data frame is a table of two-dimensional array. A table or a two-dimensional array-like structure with each column contains values of one variable and another column have the values of another set. Okay, so in this case the value in the column is, the first column is sender's address and another column is destination address. Okay, the destination address defines where the packet is to go, and the sender's address helps the recipient acknowledge the receipt. Frames could be of fixed size or variable size. The data frame could be fixed or variable size. In fixed size framing, there is no need for defining the boundaries of the frame, as the size itself can be used to define the end of the frame and the beginning of the next frame. But in a variable size framing, we need a way to define the end of the frame and the beginning of the frame. Okay, so framing ni dia ada fixed size or variable size. So for variable size, we need to define the end and the beginning of the next frame. To separate one frame from the next, an 8-bit flag is added at the beginning and at the end of the frame. So for variable size frame, so there is something called flag. What is the flag? Flag is an 8-bit, or flag is a 1-byte data. So the flag is added at the beginning and the end of the frame. The beginning and the end of the frame. But the problem with that is any pattern used for the flag could also be part of the information. So there are two ways to overcome this. Okay, so the flag, because it is data, it is also data or 1-byte data. So there is a possibility that this pattern used for the flag could be similar to the data in the information. Okay, so how we can solve this problem? So to solve this problem, we can use, first is using byte stuffing, second is using bit stuffing. Okay, so okay, we will see next. Okay, frame. So this is example of a frame. The figure shows a frame in character-oriented protocol. So we have, so in this frame, what we have here, we have flag, header, trailer, flag, and the data. These are the data. So a frame typically consists of first flag. So sangat. Okay. One is flag, two is header, third is data or information, fourth is the trailer. So flag is the indication for start and end. Start and end of the frame. So kita ada dua lah. At the beginning and the end. So nanti kalau ada next frame, dia ada sama. Dia ada flag. And then header. And then data. And kita ada trailer. Ada flag. Okay. So dia akan repeat. Okay. So frame consists of flag, indication to show the start and the end of a frame. Second, header. So header, the function is to contain source and destination address, as well as other control information. Okay. Data, so data is the information lah from upper layer. Layer apa? Atas pada data link network layer, right? And fourth is the trailer. The trailer is for error detection and also for correction code. Okay, this is a byte versus bit oriented. Framing in byte oriented protocol. So data is in terms of byte. Okay. Framing in bit oriented protocols. Data of the flag. So flag is in bits. Okay. Like this is bits of 0, 1, 1, 1, 1, 1, 1, 0. There are 6 of 1, right? 0. So 8 bits. 8 bits equal to 1 byte. Okay. So there is a particular pattern for flag, which is 0, 1, 1, 1, 1, 1, 1, 0. So whatever you see this sequence of data in the frame, that is considered as a flag. Okay, so this is flag here. Okay, byte stuffing, process of adding extra byte whenever there is an escape character or a flag character in the data. So this is byte stuffing. You use escape character. So for byte stuffing, flag header, they use escape. If there is a similar data in the information, similar data sequence like flag in the information. Okay. So frame send, they put the stuff, they put the escape character into the data, and then at the receiver they extract the escape. They extract this, and then you receive the data. You receive the data as the data sent. Byte stuffing and unstuffing at the receiver and the sender. Okay. Byte stuffing is the process of adding one extra byte whenever there is a flag or escape character in the text. This is the description for the previous figure. So whenever there is a flag similar to flag data in the text, in the information, then the system will put or will stuff, will insert escape character. Alright. So that is known as byte stuffing. Point-to-point protocol is a byte-oriented protocol. Okay. So this is for bit-oriented protocol. So bit. Just now byte. This is bits. Bits oriented. So in bits you have flag, like I mentioned just now, 0 1 1 1 1 1 1 0. So this is flag. But if in the text there is a same sequence like this, then you need to put bit stuffing. So bit stuffing is a process of adding one extra 0 whenever 5 consecutive ones follow a 0 in the data, so that the receiver does not mistake the patterns flag for a flag. The pattern 0 is 1 1 1 1 0 for a flag. High level data link control, HDLC, is a bit-oriented protocol. So this is example of bit stuffing. Okay, so you have a flag here, 0 1 1 1 1 1 1 1 0 header. In the data, the text, suddenly in the text you got something similar like the flag right here. Okay, and here also. So in order to make the system not confused with the text and the flag, so they do the bit stuffing. So bit stuffing is inserting 0. Okay, inserting 0 if you find 5 consequence 1. Okay, so that there is no pattern similar to flag. Okay, so in the frame send, they insert or stuff zeros when there is 5 satu berturut-turut. Okay, so and sini ada lagi, masukkan satu lagi, so ada 2. There are 2 bit stuffing in this example at the sender, and this frame become extra 2 bits. Okay, at the receiver, the process of unstuff happen where the extra zeros is removed. Okay, so that the original data sent is received at the receiver. So this figure shows briefly about the process of bit stuffing and unstuffing. Bit stuffing and unstuffing. Okay, example. So example, you can read first and try. Okay, you can try first based on your understanding. So that's all for this topic for now. Thank you very much for your attention. Hope you can understand a little bit about this topic. So that's all. Until then, we will meet again in another video. Thank you very much for your support. Until then, bye-bye.